Hey guys, welcome back. Today we're going to start chapter 3 where we do a whole lot of stuff about graphs using derivative, first derivative and second derivative. And a lot of it's going to seem like review because you've done a lot of this in pre-calc, so hopefully that's good. What you really have to focus on is how you write your answers, how you justify your work, not just understanding it, but actually writing the correct notation. It's super duper important on the AP exam for free response questions. Okay, so here we go. All right, first, you probably already know how to do this. Duh, it's pretty simple. All right, if this is a graph of f of x, and it's always important to know the title of your graph, because if this was a graph of the derivative, my answers would be very different. If this is a graph of f of x, where is f of x increasing? Well, it's increasing, when it goes uphill, here and here. And if we assume arrows, then it goes on forever. So my answer, this is not exactly at 0 right here, so we're going to have to estimate, and that happens sometimes, no big deal. It's approximately from x of -3 to whatever you call this guy, don't call it 0 because it's not 0. And it doesn't have to be an exact answer, but it's not 0. I'll call it -0.2, but you could have said -0.1, you could have said 0.3. All right, and then it's increasing again from 3 to infinity if I assume arrows. Okay, that's increasing. Decreasing would be, well, the other stuff. So decreasing would be in blue if I again assume an arrow there. Now the thing with decreasing, we're going to go -infinity to -3. This point right here, again, I don't know what it is, but whatever I said the first time, I have to make sure I say it again for this part, okay? So -0.2 to 3, okay? Increasing uphill, decreasing downhill. Simple. Now, what is the formal justification for the AP exam? All right, well, let's talk about calculus lingo. All right, what can you say about the slope in the regions that are red? When the graph is increasing, what is the slope here and here? And hopefully you're seeing that that's a positive slope. So increasing is a positive slope. Now just change that word slope to a more calculus type word. And the definition, the formal definition for increasing is the derivative is positive. Derivative is positive. Now, you may think, why are we even making such a big deal of this? This is actually used for word problems. They're going to ask, when is the number of people in line increasing? When is the water in the tank increasing? So we're going to use this for more than just graphs, and you have to know these definitions, okay? Decreasing is going to be when the slope is negative. Derivative is negative. Okay, so that's increasing and decreasing. And if you want, you could put that on your notes right now, if you've printed them out already. Okay, the next important term that you'll need to know is critical point. A critical point. Critical points, and you'll have to know this definition cold. Critical points are defined to be where the derivative is either 0 or undefined. Derivative is 0 or undefined. Well, derivative is slope, so that's where my slope is 0 or undefined. Now, I don't have any undefined ones here, but an undefined critical point would be a sharp point, something like that, okay? It could also be, though, remember, undefined could also be a vertical tangent. So it could look like this, if this was a vertical tangent right there. All right, so critical points. Derivative is 0 or undefined. Now, out of those critical points come our maxes and mins, what we call a relative or local max, or relative or local min. And it's kind of common sense. Duh, I can see, well, this appears to be a maximum right here. This is probably a minimum. Not very hard to see it on the graph, but you're going to have to recognize it with word problems and such. So, yes, this is my maximum right here, but what would that definition be? Let's talk about the derivative. So to be a maximum, first, it has to be a critical point. So first, the derivative has to be 0 or undefined. And next, What happens to the slope at a maximum? The slope goes from positive to negative. So the derivative changes from positive to negative. Minimums. You can see that those look like they're minimums, local minimums, relative minimums. But what would be the definition? First, it has to be a critical point. So the derivative has to be 0 or undefined. Oops, sorry. Jumped ahead. So first, the derivative has to be 0 or undefined. But then to be a minimum, here and here, the derivative changes from negative to positive. Negative to positive. So here are all of your justifications. And you probably want to make sure you write those down. You have to have this memorized cold. And if you print out the worksheet for today's work, all of these definitions are in that worksheet. Okay? Or better yet, study right now and then try to do the worksheet like it's a quiz. Okay, one more. Let's do it again. Ready? Critical points. Your critical points would be, hopefully you're picking those out right now. Okay, critical points look like maxes and mins. Here's one, and here's one. Okay, this sharp point is still a critical point. That's where the derivative is undefined. Okay, now remember, when the derivative is undefined, it can either look like a sharp point or a vertical tangent. If you visualize a sideways parabola, well, that's not a function. So how about this guy? Almost a parabola, and then I decide to switch. That would make this right here would be sorry, I missed it. This guy right here would be where the derivative is undefined because it's a vertical tangent. Okay? All right, so we have our critical points. All those red dots are critical points. Out of those critical points, which ones are maximums, local maximums? You've got one here. Local minimums here and here. Okay? Where is f of x if this is f of x? Where is f of x increasing? Here and here. Where is it decreasing? Here and here. Easy. Okay? So that seems pretty basic, but trust me, we use this a lot. It matters a lot. Make sure you know those definitions cold, not just by looking at the graph, because we're going to mess with you. You won't be able to see that graph. You're going to have to know the definitions without the graph. Okay, now let's assume you don't have the graph, although honestly this is a simple polynomial, so you can kind of figure out what this is. Now be warned, pay attention to whether I give you the original function or the derivative. In this problem, I'm giving you the derivative. So I've already found the derivative and factored. In your homework, you have to first get the derivative and factor. Okay? So let's assume we've already found the derivative and we've factored. Now, to answer all of these questions, we're going to do a first derivative sign chart. Okay? So we'll do a first derivative sign chart, just like you did with acceleration and moving left and right. So we're going to first find when is the derivative 0 or undefined, and that would be at -2 and 1. Then, to answer all these questions, we just need to figure out what's the value of my derivative in each region. So, checking the region to the left of -2, if I plug in a -3 to both factors, then the first factor would be negative and the second factor would be negative, so that multiplies to a positive. If I plug in a 0 for this region, my first factor is positive, my second factor is negative, so that gives me a negative. And if I plug in a +2, I get positive, positive. So there we go. Now, what does this tell me? F of x is increasing when, what's the definition? And you want to always write that definition. F of x is increasing when f prime is positive. Okay, well, this is f prime that I have on my sign chart. So f of x, even though f of x isn't given, this is describing f of x. Okay, so f of x will be increasing in the regions where f prime is positive. But you do have to write that in interval notation. So f of x is increasing from -∞ to -2 and from 1 to infinity. Okay, f of x is decreasing when f prime is negative. And this is f prime, so it's decreasing in that middle section from -2 to 1. Okay, maximums and minimums. First of all, the derivative has to be 0 or undefined. So first it has to be a critical point. So these are my possibilities for maximums and minimums. If the derivative changes from positive to negative, uphill to downhill, then it's a maximum. So at -2, you have a maximum. So max when x equals -2. Okay? If the derivative changes from downhill to uphill, negative to positive, then you have a minimum. So there's a minimum at 1. Okay? Now, to sketch a possible graph, I kind of need to clean this up. First of all, this is a parabola. This derivative is a parabola. If the derivative is a parabola, then the original function was a cubic. So I can kind of already guess what this is going to look like because I took it easy for this one. So this is going to be a very sloppy sketch. I don't really know. I know that at -2 I have a maximum, but I don't know how high up it goes. And I know at 1 I have a minimum, but I don't know how low it goes. I don't know the y-intercept. I don't know much. Okay? I also know that my graph starts off going uphill, then downhill, then uphill. Uphill, downhill, uphill. And like I said, that's a positive cubic. You can kind of have predicted that because I gave you kind of an easy example. Okay, so your homework right now is just really trying to learn what the different terms mean and applying it to graphing. So good luck.